Welcome to Season 7 of the Prosthetics and Orthotics podcast. This is where we chat with experts in the field, patients who use these devices, physical therapists, and the vendors who make it all happen. Our goal? To share stories, tips, and insights that ultimately help our patients get the best possible outcomes. Tune in and join the conversation. We are thrilled you are here and hope it is the highlight of your day. Hello, everyone. This is the Prosthetics and Orthotics podcast with Joris Peels and Brent Wright. Joris, how you doing, man?
I'm good. How are you?
Does it feel a little bit weird to be on the receiving side of that conversation?
Strange. It's super strange, dude.
Well, we'll explain a little bit later on why that happened because Joris will be introducing our guest today. But so yeah, man, what you up to? Still coming down off the Form Next stuff?
Yeah, so a lot of work, a lot of interviews with people, a lot of like kind of tidying up the end of the year kind of stuff. How about yourself?
Yeah, well, you know what's been crazy is these flexible things. You know, I know we talk about TPU and such, and really, I think it's a game changing, regardless of the technology. The body specifically for O&P is a living, breathing thing, and it's moving all the time. And I believe prostheses and orthoses need to be made in that manner. And so what we've been doing lately is to see how much we can make flexible, and really push the limits. And so we're breaking a lot of rules. And it's been amazingly interesting. And the feedback that we're getting back from patients is incredible.
Okay, that's good. Yeah, I saw some stuff you're doing on LinkedIn. The last kind of leg you made, that was amazing, dude.
It's really wild. I can't wait to fit it. It's actually for another clinician, but it's a long-term patient of mine, and so I know him pretty well. And so when I had that discussion with him, he's like, "Hey, man, yeah, we'll try it." He said, "It seems like every time we iterate, it gets better for me." So he's kind of a guinea pig on that. But you know what's neat is with this added flexibility, it's almost like a little bit of a shock absorber. And so there's always the potential of failures regardless of additive manufacturing or traditional manufacturing. And so what you go back to is, why did it fail? And typically there's some sort of event that happens, a fall, somebody gets hit, the socket is run over by somebody's electric wheelchair, or the dog gets all these things. And but one of the things that can prevent some of these failures is flexibility. And so I think this is another interesting step moving forward in specifically additive manufacturing, is those failures that may have been happening, and I'll be honest, I've had failures with the additive manufactured sockets, and I've had failures with traditionally fabricated sockets, but those failures I believe will truly be minimized with flexible sockets. I really do.
Okay, all right, we'll see. It's you're at the head of that, dude, and I think it's a really, really exciting development.
So the kicker is it's hard to design for. It's you've got not only the lattice structures, thick and thin, some loading stuff. So, but I think it's an exciting time. All right, Joris. I mean, we just went into the weeds a little bit about that TPU stuff, but I wanted to get to our sponsor. We have a sponsor. They've been sponsoring us. They did last episode, and they're going to do it all through season 7, the rest of season 7 here. And that is Coyote. And so I'm really excited to have them on, and I know you're a fan of them as well.
I'm a huge fan. Like, I think, I think it's. I like the fact that they seem very hands-on. That they started as just this is an extension of their office, really, and they started by just inventing devices, just like everyone in your industry kind of does, and they just took it to a whole new level with all these like to me, they seem really innovative, but also really niche, like really small products that kind of like have a really, really beautiful place.
Yeah, well, and that's what's neat about this dynamic strut. We talk about prosthetics a lot on the podcast, but the reality is there is much more of a population that need some sort of orthosis or ankle foot orthosis. And one thing that I love about their dynamic strut and how it relates to 3D printing is that you actually have this modular system. Then you have like a cuff strap that goes up on your calf. Then you have this area that goes into your shoe. And then if you want to, you can have another part that goes almost like a shin guard on your on the front part of your shin. But what's awesome about that is it makes it very cost effective to 3D print these braces, as well as have a dynamic piece that connects the two together. I think that's amazing.
Well, that's super cool. That's really good. And do you use this at all, Brent, at all?
Oh, I love this strut. It's actually my go-to strut. I don't use anything else. There are some other brands out there, but and here's why is they were very intentional on how they fabricated the strut, not only the resins, the materials that went into it. And so everything was, specified, and it's not stiff.
All right, that sounds really cool, man. And thank you so much for Coyote Prosthetics for sponsoring us.
Who do we have on the show today?
Well, that's actually kind of funny because so Brent actually surprises me with the guest every week. I don't know who the guest is, right? That's the whole central conceit. So sometimes it's a bit kind of like I'm trying to kind of feel through the first couple of minutes trying to figure out who it is. I have no idea. And this time Brent found the guest, but it's actually Antonius Kuster, and he is somebody I've known for a very long time. I did a keynote once for 3D printing show in 2014 or something in Germany, and he actually introduced me, and he's part of the people that organized that Erfurt show and stuff. So I've known him for a long time, and so that's actually it was a hell of a surprise just now. So Antonius is somebody who has an eponymous company called Antonius Kuster as well, and it's a German company, and he started as a pattern maker, mold maker using traditional manufacturing techniques many years ago. And then transitioned more and more to 3D printed patterns and molds and 3D printing design, 3D printing as a service, and also 3D scanning as a service. He does a hell of a lot of 3D scanning consulting, 3D scanning training, software, very difficult projects that no one else can do, and also helps a lot of orthotics and prosthetics people with 3D scanning as well, and is also an expert on the 3D scanning software. So thanks so much for coming on the show, Antonius.
Thanks, Joris, for the invitation to join this podcast. So, yeah, it's a long story where we started, and I'm curious about your question.
Sure. So first off, when did you were just doing traditional pattern making, mold making, right? When you got started, that's how you got started in industry, right?
Yeah. So this is I after high school I did my apprenticeship as a pattern maker. So really turning wood into the patterns for casting, for foundries, and design models, vacuum forming models for packaging. Later on, I went into mold making for wax injection molding for investment casting. And when I finished my apprenticeship, I went into a prototype mold making company. And this was in 1989. And there I saw the first 3D CAD CAM application where I saw something moving on the screen in the morning, and I put this part I saw virtually from the CNC milling machine in the afternoon, and this made me change my mind that now computers make sense for craftsmanship and in my business, because this allowed me now to mirror, to scale, to turn something positive into a negative mold. And starting from that day, I spent a lot of time into learning 3D technologies.
Okay, but one thing that's really interesting is this thing you touched on it, that you were an apprentice, right? In America, for example, the system is you send everybody to college and then they all get kind of a education. But Germany still has this apprenticeship system, which is quite unique, actually, where you literally after high school you go really really deep in learning a particular skill. rather than getting a broader college education. Do you think that was really valuable of you to really understand this really deep, this mold making, this die making kind of technology?
I think it's not just for mold making and die making. It's the mix. So normally after high school, you are qualified to go to university. And for me, the first intention was I want to have more practice for my initial plan to get to study industrial design. So I want to learn more about materials, about manufacturing, and this was my initial intention. So normally, you make an apprenticeship when you have the more basic school education. Um, but I think it's a important way of our education and our small and medium sized businesses here in Germany that we have this dual education. So you have your apprenticeship in craftsmanship or in industry. Parallel to that, you have school education. And then sometimes you have even additional education in dedicated institutes that go deeper into, for example, as a pattern maker, we had 3 courses with CNC, 3D CAD, with materials. So we learned a lot about plastics, resins, and how to work with carbon fibers, for example, and glass fibers. And so this was more alignment of all the apprentices to learn everything which is necessary for this business. And I think this the important is this standard that normally if you hire someone who finished an apprenticeship, you know what he should be capable.
Okay, it sounds really solid. I really think more countries should look into this, especially with like very technical kind of jobs that are very in demand now. And I think it'd be really wonderful for more people to do it. So tell us a little about mold and pattern making, just generally. So usually it's kind of it has to be very precise or quite precise, and you're usually looking at a bunch of different steps, right, depending on the process, right?
Yes, correct. So we started with drawings. Then, of course, you have to take care about the demolding. So, are there undercuts or not? Where's the optimal parting line? Then, what needs to be machined after casting? So, you need offsets. Then, of course, to work with tolerances. What is the estimated shrinkage of the metal when it cools down? What is the tolerance that, for example, scent cores have to fit? If you have, you might imagine in the company where I made my apprenticeship, we even made the casting patterns for Formula One engines. And this is really artwork. So there is a team of 4 or 5 people working on 2 months to work on all these parts from drawing at that time. So, of course, my colleagues at that time told me this will never be done with computers. But this happened much faster than they expected. But I learned a lot about materials, tolerances, manufacturing processes, and the challenges sometimes you face when you have to do something manually.
No, totally. And so then to go to CNC was already like a crazy big step, right? So we're talking that's in part this digitization as well. CNC, of course, very precise technology. You need a lot of operator skill. Undercuts, for example, really problematic. How'd you find like switching to CNC?
This was cool. So we started with simple things, just milling outlines. So it's more 2D, 2.5D, where you do the G codes on the controller of the CNC mill. The next step was then going into 3D CAD, whereas 3D CAD in 1990s was totally different to what we have today, where we have full parametric historical CAD systems. At that time, it was surface modeling, and you had a limited number of tool path strategies, but it went very quickly. So that in 1991, beginning of 1991, I started with 3-axis milling already in my last employment, and and this is not just milling. Before you have to mill, at that time, we turned drawings into 3D files. So I think this is important. This was not at that time. It was not normal that you already got 3D files from your customers, mostly automotive. So this started with a little bit delay afterwards. But I think the most important step was the 3D design. So the preparation for the mold on the screen, then turning this into a milling strategy with roughing, with finishing, with selecting the right tools, and how to orient the parts on the milling machine. And this was then, of course, the basis for my first 3D print as well.
Okay. So first off, CAD, you said to yourself, like, it was different then, but I think you're really downplaying it a little bit, because it was, of course, ridiculously slow and cumbersome, and the computers were slow, and it was very difficult, right?
Yes. So you might remember the 286 computers, or XT computers. Mm-hmm. So was not comparable with what we have today. And when the milling tool path was maybe it had to fit on a very small diskette, and so what we now know as a symbol, a icon for saving, was physically available.
I was once giving a training to a bunch of 12-year-olds on how to 3D print, right? And we're using, I don't know what we're using again, like some program. I said, like, click on the disk. And then the kid's like, what's the disk? Like, what is the disk? And then I had to explain to these kids what a disk was. And like there was like a little disk icon for the save. And they had no idea that thing was actually a reference to like a physical object that we used to like put stuff on. They're just looking at me like really weird, like, what?
Yeah. And we discussed during my apprenticeship, when we had our first courses in CNC milling, we discussed, because no one had a computer at home, we discussed about should we buy a pre-formatted disk, or should we format the disk in the school? So, and we spent a lot of time into this.
Oh wow!
So, it was crazy.
And how about like 3D modeling at the time? Is like, were there like a lot more constraints? Did you have to wait a long time? Like just the actual 3D modeling was actually also really complicated, right?
Yes, because it was mostly freeform surfaces. So you had to understand how you use splines and curves, turn them into faces. And then if the next step is, then you had to design the fillets. And so this was really totally different. But the benefit was that when you had a more flexible design tool, I used Cimatron at that time, and so it allows us, when you knew, okay, I'm milling and my smallest tool will be maybe 6 millimeter diameter, so there could have been holes in my data set. As long as they are smaller than the tool tip, there was no risk. So today, very often you run into situations where your CAD design fails, where maybe different surfaces connect in a strange way each other, and where you need some fillets and so on, and it didn't work. But at that time, there was always, okay, it was more, you had more tolerance. So it allowed you more to improvise. And I think this was really important at that time to learn. And it helps me a lot today when something fails in CAD, especially when for my younger employees, that, okay, you have now 3 boundaries, turn it into 4 boundaries. And then it works. And like, why? Okay, I can explain how it was 30 years ago or 35 years ago. And you need to have UVs in the surface description, and a triangle is normally not supported by CAD.
Oh, goodness. Okay, and what was it? Well, so that could have been a little bit problematic for your first 3D print, right? What was that like?
This was in 1991 already.
Wow, that's very early. So it's SLA and
yeah. As it was SLS on a DTM laser sintering machine. So the first demo machine set up close to the company where I worked in my last employment. And so I heard about this machine, and we worked on a prototype for a roof rail carrier. And so we need the 3D files. We had to mill in aluminum and steel. And then there was a small cover housing for the key. And I asked my boss at that time, there are some undercuts. Won't you try this new technology once? And I got the offer to test it for free if the parts are not too big. And so we prepared the files. The challenge at that time was, because we had no solid modeling, you had to turn every patch into triangles, and then you had to check if the triangles have the normals into the right direction. So you could spend several hours on the screen looking around so that you had a closed STL file. This was the first challenge, but it worked. And we already learned a little bit about this, so that we exported portions of the file. And we learned that at that time it was the ASCII format for STLs. You just could combine them with a batch file, so which helped us to even manage larger things. But we got the parts a little bit with steps and rough. So laser sintering at that time needs still to have some smoothing and some infiltration with resin. But we were already talking about, okay, in the future, we will no longer work on stock. We will work on demand, and we will do custom parts. And this was 33 years ago. So, and we are still far away from that.
Yeah, I was a bit optimistic. And was it really this one defining moment? Because like a lot of people have this one moment where like, ta-da, everything changes. Or was it with you just a gradual realization that, okay, wait a minute, this actually works?
For me, it's because I had these moments with CAD, with CNC milling. I always a little bit critical. Okay, this is what I learned now after several years, that after the proof that something is possible, it might take additional 15 years for a broader acceptance of the technology. So, and in most areas, it's or in most companies, new technologies enter the shop room when there is a switch in generations. So when someone new gets into the team, and I think this was my experience there, and I had to I had to fight against some of my colleagues in that last company. Because we introduced with a colleague, we introduced the whole 3D technology with CAD, with milling, CNC, 3D CNC milling, and we just somehow hijacked the shop room.
Oh, that's really cool. And then, did you see it more and more, or did you really have to specialize before it? Like you could really see more 3D printed stuff. Or when did you really start doing this kind of like full time?
Oh, I think this started more. So I founded my own company on New Year's Eve in 1994, so 30 years ago now. And in the beginning, it was just service providing. So the same what I did in my last employment, 3D CAD design drawings into 3D files, and we offered even the toolpath calculation. So we introduced the CNC milling, 3-axis CNC milling into smaller shop rooms, and we offered 3D design services even for bigger companies in their product development. And I think we went more and more into 3D printing when the need for prototypes increased. So I purchased my first 3D printer in 2008. It's an Objet Eden from now Stratasys 260V. So this was a birthday present for my wife. She was really happy.
it was 30,000. It was 30,000 euros at the time,
yeah. Oh, yeah. A little bit more,
really?
much more. So I think
the bigger
it was
one.
70,000.
Yeah.
260V.
Oh no, yeah, the one that broke all the time.
Yeah, it's still working.
Really?
It's still working, and yes, and but before that, I used external service providers when we went into figurative stuff. So for toy designers, and we worked for some toy companies here in Germany, and when we worked on new prototypes and we had some changes, then just for the approval, we used 3D printing. And so this was, I think, we started with that already in 2004, 2005.
Okay, and then Objet, we don't really talk about it. It's PolyJet, right? Now, this is a technology that uses inkjet and extrusion of a resin, let's say, and flash with the UV, and then you get a model that has like kind of like a hair gel kind of consistency support material inside of it, let's say. Was that easy to use in the beginning? Because it's a really expensive material.
This was this was really the decision that when we worked more with, at that time, even with dental customers, so that we printed 3D models for dentures, and we went into feasibility studies there, and I think. The benefit of those systems was you just load the STL file of your shape. It takes all the systems intelligence for support, and the only thing is the material is still really expensive, but the precision is high. So they have 16 micron layers and 600 dpi resolution in the flat surface, and it allows us really to print hours without any problems. And so we used it a lot for this organic design stuff, and this was maybe when we searched for additional 3D design tools that allowed us to turn those shapes into digital manufacturing that has been formerly used by copy milling and maybe working with resin molds, with some hand sculpting tasks. And this was our challenge when we went more away from automotive general machining industry into what we call organic or anatomic shapes. So in the beginning, it has been glass molds, figurative stuff. So the US people know Gorham, Lennox, and maybe all this kitschy glass stuff, figurines for Christmas trees. And I made some angels and dolphins as candlelights and crazy stuff. But we turned weeks into days for finishing the design and turning this into a steel mold at the beginning. And then we used already 3D printing for the approval of the necessary changes to make things moldable.
Okay, that already saved weeks. Yeah. And when did you stay with Objet for a long time, or did you go into other technologies, or what did you use?
We have now two race printers, Race Pro 2 and Pro 3, and we have a snap maker, but those devices are more for feasibility studies, for demo projects, and for supporting some customers that use the same printers for in-house. Of course, externally, we use all the other things like laser sintering, multi-jet fusion, and even, if necessary, metal printing. So since we switched more from a 3D CAD service provider or CAD/CAM service provider more into a solution provider. So since 2003-4, we started to sell products we use in-house. Our major product is Geomagic Freeform, so which in the beginning was our solution to turn this handcrafted models and shapes into manufacturing. So where normal CAD really fails, this was our Swiss knife and the secret tool that solved the problems. And from there, we went into more and more projects where customers purchased the same products we use. So that at that time, the sensible salespeople asked us if we don't want to become reseller of those products, because we have been more successful with our feasibility studies and projects than they have been with their sales team. And I think this is now the key of our business and our long-term success. So that we use the manufacturing background, the know-how we have from materials, and how things get processed. And then we teach customers how to turn their ideas into 3D designs and use the right manufacturing technology. For us, it's not just 3D printing. We are talking more about digital manufacturing. If something is cheaper to mill, we recommend milling. If something is simple enough to make a mold, then it makes sense to make a mold. This can be 3D printed as well. But if things get more and more demanding on shapes, and when you want to design around functionality, then of course 3D printing is the way to go, with all the materials we are getting and the freedom of design we are now having.
So, sort of design side of the business, I guess you would say. When you say that you moved to freeform because some of the CAD tools were failing you, what do you mean by that? And I think it's just a real important thing for our audience to grasp on. CAD tools doesn't necessarily mean you're going to have a good product. There's definitely some other options, and you called freeform the secret weapon. So I'd love for you to expand on that.
Yeah. So the thing is, we know how to handle 3D tools, but we learn a lot from our customers about their processes and about their needs. And of course, and about their timelines. So especially in craftsmanship, you know this from orthotics and prosthetics, it makes no sense to do the classical CAD way, to scan something, to do a classical reverse engineering, and try to use somehow bad surfaces in CAD to resculpt them, to bend the data, and to reduce the data, maybe to shrink them. In CAD, there is no tool to do something a little bit or to smooth something a little bit, and a little bit is something you can't measure. This is something you have to it's a subjective things. So it's based on experience, and no one can tell you how many digits. And I think where or where we, for example, look which tools are they using. The best preparation for a totally unexperienced CPO when he wants to go into digital is that he takes some notes, pictures, records on his traditional manual workflow. So how does he take a cast? Where does he take care about the position, the angles, where he compress and where he corrects? Then when he makes the positive, so where he removes material, where he adds material, which tools are they using? And these are rasps, these are shapers. And I think this is important, that in CAD, to get to the similar shapes just with surfacing, extrusion, and some other tools is very, very abstract, and it's not the digital way of sculpting. And I think CAD is more a technical approach, which makes sense, especially for parts and objects with a long life cycle, where it makes sense to have a lot of connections between the data, so that there is a real parametric tree, and where all these things with constraints are connected. But when you do a single part, which is for one individual, and it will be done once, of course you will do a similar process a second time, but there is you need a very, very effective way to get this organic shape ready for manufacturing. And when you need to smooth something quickly, there is no surface tool which allows you to do this.
I think that's a really, really good point. I think it's a really, really good point, especially for OMP. So, and for you, like, so you came from this very engineering background. What was it like for you working in OMP? Was it crazy in the beginning? Was it like, what are these people? This is the journey for me. It's like, what are they doing? It's like art and artisan and engineering and medical. It's like this crazy mix. Did you find that too? It's very compelling, but also very strange, right?
This was funny because in the beginning it was more like, okay, I always saw my job a little bit like a challenge. So when someone claims this is not possible, I take this personal and try to find the way how to make this happen. So this is one of our mottos. We try to make the impossible possible. And or when we went deeper into orthotics and prosthetics, this happened at one Euromold, I think in 2007 or 2008. So I got a visitor on our booth. We had been exhibitor there already. So a visitor came to our booth and he asked me, okay, we are CPOs and we are considering to go deeper into digital manufacturing. And we think that you might be the right partner to support us. We know you have no background in prosthetics and orthotics, but we know you have a good background in manufacturing, and you are creative and open-minded. And okay, we made a appointment, and I had to prove that we are able to 3D scan a gypsum cast of a leg. Then they asked me, okay, take this 3D file, show us some tools, how you can offset, how you can modify, how you can change the shape. And then at that time, we were not directly talking about 3D printing. It was more milling at that time. and then let this 3D data set be milled, and then we want to compare the cast with the 3D milled result. First challenge was that I asked a company, a friend of mine, okay, can you do the milling for me? And I got the milled part, and it was a totally different size. And I asked him what went wrong. And he told me, oh, we didn't have the big machine available. So I scaled down the data set that it fits to the machine. And then I had to explain him that this is exactly what he should not do. We can split this into two parts to mill it on the small machine and glue it together or assemble it somehow. But it's very, very important that the data we use now for manufacturing really fit 100% to the original shapes. And so we then made a presentation about this result, and we got the go. And then the big challenge for me was a 2-day workshop with 12 master CPOs that gave me a crash course in orthotics and prosthetics. So, and they were really highly engaged. This was really impressive. And so they explained me different types of foot orthotics and of spine orthotics, of helmets. And one task was the individual seat foams for wheelchairs. And while they told me how they do it manually, I demonstrated what's possible digitally. And this was the initial content for the first courses we offered them, and we helped them to find milling machines, and we helped them to find the right milling tools and materials. First, to substitute the heavy gypsum cast against a milled foam part. And then, obviously, the next step was naturally they go into 3D printing. And so there was of course, there was a delay of maybe 4 or 5 years. But at that time, it was very important that they started first to turn the 3D scan into a good working digital cast model and mill it and do the vacuum forming so that they trust the digital workflow. And then, of course, next step was more like, okay, when it gets more complicated, they went into 3D printing. And for us, it's parallel. Now it looks quite different. Now we have more new customers, prospects that have already some people with more computer experience and with some 3D background, and they want to go into 3D printing directly.
Do you have any advice for, like, imagine I'm a CPO and I want to do the whole scan to 3D print kind of workflow? Do you have any advice on these people how to get started and how to do that successfully?
The very important is what did we learn from those who started twice or 3 times? So the important thing is that you have first a plan. So when do you want to, or in which area do you want to go digital first? And very, very important, take care that you have time and free capacities for this. So the introducing 3D technologies is nothing that you can do very, very quickly aside of your full-time job. So you have to spend time for this, minimum 1 day per week for introduction, and then start with simple cases, maybe AFOs, that are not too big for failures. And very important, what we learned, and this was one of the biggest challenge, and we found I think a cool idea. they have, when you go into 3D printing, you substitute your traditional material with new materials. And there is no background about these new materials, no experience. And we want to prevent the bad experience that most critical people in the team, they are happy when something fails. But we learned it's very, very important that they get a feeling, a haptic feeling of the material. So to support this training, we developed a data set for 5 shells of a AFO design that fit to each other like a Russian matryoshka puppet. So you can slip each one over the other with 1 millimeter gap, and this data set can be printed in one build job. So it has the expenses of a single DAFO or AFO, and delivers you now the information. Okay, this is how this material behaves in 1 millimeter thickness, 1.25, 1.52, and 2.5 millimeters. So they can bend it. They can see how it acts where you are flat. They can check how it's when you have concave, convex areas where it's going to get more rigid, and how there's a perforated area. There you see how this flexes. And what we recommend is that they use this data set and ask their intended service provider to make prints with all the available materials so that they can test internally and check, okay, we now substitute polypropylene 2 millimeters with PA11 1.5 millimeters, for example. And they can discuss with the same samples with physiotherapists and with the clinics as well. So for us, it's very, very important that before they invest into own printers, they need to learn to design, and they need to learn about the available materials. So it's just like first you need the driving license, and you have to make the content before you buy a car. So this is our recommendation.
I think that's a really, really good advice. I think it's really solid. I mean, and a lot of people just jump in there, buy a giant machine, or just try to jump in there with critical stuff right away. I think your method seems to be much, much better. Also, one thing that's really interesting, I've been looking at your website, and you guys sell scanners, and it's really interesting that you guys sell, well, Artex scanners, which I think for some applications, especially body scanners like the Spider and the Arctic Leo and stuff, are some of the gold standard scanners. The Arctic Leo is insane, but ridiculously expensive as well. And you also resell Shining Einscans, right? And those are really quite inexpensive. And those are actually also the two that I would recommend. And I also happen to know that from a completely different basis, Brent also likes both those families of scanners. Like, is that just a coincidence? You like the same ones as well, or?
It depends on. So there are two things. Historically, the Arctic scanners have been available before Shining, and therefore, of course, we started with EVA and with Space Spider, and later with Leo. And of course, Artec has a very, very successful software development, so that, for example, get shapes captured with EVA, even a 10-year-old EVA, which have been impossible in the past. So that due to a software update, you get, like a new scanner. So Artec is very successful on the software side. But on the other hand, we did a lot of trials, and we have been joining a research project where we tested, I think, around 20 different scanners. And we took a reference scan with a auto scanner, which is used for quality control in automotive. And we scanned 2 Mannequins. And then with every scanner, we got every one of my team had to make 5 scans, and we compared all these scans. We took a look at the cheaper structure sensors on the iPad. We took a look at all the Shining scanners, Calibri, and the Artex scanners. So not just the products we sell. And then, of course, you recognize, okay, what is the expectation on the scanner? And what is the budget available to introduce the technology? And sometimes the budget is limited. And then, of course, it makes more sense to buy a cheaper scanner and combine it with freeform to have the full data set for your digital showroom, instead of buying just an expensive scanner and have no design capacities. And I think this is important. We think that in the future, you will have different scanners with different focus on their use. So this is when you have to go mobile, you might use a Leo because every scan is successful, or maybe something mobile which arises in the near future. So there are new things coming on the market. And then, of course, if you are stationary, it might be much faster to work with a wired scanner because the data are immediately on your laptop to finalize the data. And I think it depends a little bit on how flexible should the scanner be used. And we benchmark scanners. And when it makes sense for us, we purchase them even for us in-house. And obviously, then we are interested to sell those products as well, to share the knowledge we gained with those tools. But there is not just the one right scanner. So even Artex scanning can be complex, and other devices, if they deliver the same precision as needed, for us, a full package might be even an Einstar with your Magic Freeform.
Okay, I think that's really good sound advice on the scanning as well. Hey, Antonius, thank you so much for being here today. This is absolutely wonderful.
Thank you. You're welcome.
And Brent, thank you for being here as well.
Oh, this was great. And thank you, Antonius, for, sharing your knowledge to those like me as well. And so, I love seeing the stuff that you're up to, and I love, collaborating to whatever extent that looks like, but it's fun. And we have so much more to get into. So, it's up to yours, but I think we'd watch you back.
No,
Yeah.
we totally want Antonius back.
You should have taken a picture of my table. So I put a lot of samples on the table, and so if we had used the camera, we could have shared some images, and you got a rough idea about this sample set, for example. Maybe we make another podcast as well.
I think that's in the cards for sure. So we'll see about getting that set up for the new year. I think that would be great because there's so much more that that we didn't cover. And I really appreciate your time. This was great, and it's a perfect segue, and it's a perfect amount of information for our listeners to go to the next level.
I really invite you all to visit us at the OT World in Leipzig next year in May. So this is where we have a large booth with a presentation stage, and where we really go deeper into this and try to explain the products we offer.
So, hey, this is a wonderful episode. I hope you enjoyed it too. We loved it. And, thank you so much for Coyote Prosthetics for sponsoring this episode. And head over to coyote.us if you want to check them out. They're great folks and great products, so that's always easy sell from us. And I hope that you enjoy working with them.